This comprehensive course compiles my previous videos, incorporating intentional modifications tailored for individuals seeking an end-to-end Python-based automated trading setup, using TradingView webhooks and executing trades through a brokerage. This implementation is entirely free, barring the optional cloud hosting of the web receiver. Alternatively, you can host it on your home computer if continuous, uninterrupted activity isn't a priority for you. This video has 4 segments. Setting up an API server or web receiver. Hooking up a TradingView alert to the web receiver. Deploying the web receiver onto the cloud. Setting up a broker for algorithmic trading. This section will walk through how to set up an API server using Bottle on Ubuntu machine. Since this is a vanilla Ubuntu, we need to set up some basic packages before setting up Bottle, including setting up in virtual environment. Then we'll walk through the Python Bottle installation, which is the core of this API server. This is a lightweight web framework for Python and easy to install and write code. Once we have them installed, we'll write a very simple get and post method. The get calls are just used for querying, whereas post calls can be used to take some action. You can pass payload as part of post. Finally, we will write the post method to process the data and take some action item based on the payload. This is a Ubuntu virtual machine running on my Mac. This VM is set up freshly, so we need to even set up the sudo permission for the VBox user. It's always safe to not use root and use with a sudo access of any user. To set up the sudo access, we will first have to get into su, use the vsudo. Add the VBox user as part of the sudo access list. Save and exit. Now exit the su mode also. Now, you can see that you have sudo permission to install any package, which requires sudo access. Now, we need to install pip, which will be used to install the Python packages. Recent Linux are so user-friendly, just typing the missing command just lists out what package needs to be installed. Here, it says to install Python 3 pip. Let's install it. Looks like it requires sudo access. Now let's run the same command with sudo privilege. Let's also check if Python 3 is also working fine. Good, it's working too. Now, we need to install the virtual env. This is a great tool. If we want to run multiple applications on the same VM, and each requires different packages and versions, then, virtual env is the right tool to use. But, here looks like we don't have virtual env, but we know that we need to install Python 3 virtual env package. Let's install that now. Now, it's installed, let's create a new directory called API server to place our code and set up the virtual env. Creating an virtual env named API env. It got created, but to get into that environment, we need to activate it. Sourcing the activate file under bin will activate it. You can see that the prompt is prefixed with the environment name. In this environment, let's now install Bottle. For installing the Python package, we will use pip, which we installed earlier. The Python package for Bottle is Bottle. Now, let's create a file called app.py, and write a small code for version call. You need to first import root and run from Bottle. The root decorator is where you define the path of your API. Here, we will define the version call with API v1 version. You can give any function name. In this function, we will just return the JSON dictionary with version set to 1.0. For running this program, we will have to specify which interface and the port. Here we have defined with 0.0.0.0, which is the local host or the default interface. The port is set to 8080. We can set or route it to default port, but that setting is not covered in this video. Save the file and quit. Now, for running the program, just type python app.py. This now says that it's listening on http://0.0.0.0:8080. I am going to use Postman, which is an API client for sending the request. The IP address of the VM is 192.168.86.45. We will need to construct the API endpoint like http://192.168.86.45/API/v1/version and hit the send. There seemed to be an error. The reason is, if we do not specify the port, it will default to port 80. Since we are listening on port 8080, we will have to pass the port also along with the URL. Now you can see that the request reached the API server and also it returned the version value. Great, we are able to successfully write the first GET API call and get a response. Now, let's move on to writing a post call with some parameter. It's almost similar to the GET, but we will need to do some parsing of the value being passed using request. A return value is optional based on whether if you want the client know whether the operation was successful or not. Here, we will return a string with success. Save and quit. In the postman, we will change the method from get to post. Change the endpoint. Here, we will need to send the parameters. I am sending a JSON dictionary with 2 values. You can see that. We are able to retrieve the value from the request and able to print it successfully. Also, we can see the return value with success on the Postman client. Now, let's write a small sample program to see if we receive a webhook from TradingView alert with the buy and sell signal, with the corresponding close price. How can we really write some basic trading bot? Here, I created the same post method with endpoint like TradingView alert. The alert is going to have a type, ticker and a close price. The simple logic on this code is to buy a BTC at market when buy signal is received, and close the position when sell signal is received. Also, while closing the position, calculate the P&L and print them. In the Postman, simulate as if TradingView is generating an alert with those value. To trigger the buy signal, let's first send the buy signal with some price. You can see that we are able to enter the trade with the price for ticker BTC/USD. Change the alert type to sell and increase the price by say $100 and let's see what happens. Now, the position is closed and the P&L is printed as $100 profit. This is just a bootstrap video on how to set up a basic server to write your trading bot if a webhook is configured to be received from either TradingView or any other platform. You can build your complex trading logic on top of this. This section shows how to hook trading signals to a webhook in TradingView platform. We'll walk through on how to configure the TradingView alert feature, which can generate alert on certain technical indicator conditions are met, which in turn can generate a webhook to be consumed by your trading bot. But what's webhook? The main difference between API and webhook is API is triggered manually by a client, which asks the server to get some data, for which the server responds with the relevant information asked for. But webhook is set to be triggered with any schedule or any configured conditions met automatically. If you have not used TradingView platform, this is their platform which is really powerful with technical analysis. The link to this website is visible on the top, which is tradingview.com. This is their charting area to display the price chart of the symbol along with all the indicators selected. TradingView supports lots of predefined and published technical indicators, they are so powerful. You can also create one using PineScript, but that's not the context of this video and I will not be covering it here. I will be using the supertrend indicator for today's alert configuration. You can see the buy and sell signals, I am going to use that as an alert to trigger the webhook. See, there is one buy signal just popped up. I will be using BTC/USD in the 1-minute chart for today's purpose, since it will be easy to trigger alerts in a short time for this video. Again, there are other tools in TradingView platform which are really cool, but that's not the scope here and I will be focusing on the alerts with webhooks. Let's click the alert, which will bring up the alert tab on the side. Here is where you will creating your alert, but before that I need to set up the webhook receiver. I will not be showing how to implement the webhook receiver as part of this video, but I will start them so I can show when the alert gets generated with webhook, I can receive them on the webhook receiver, which is an API server running on the cloud. I am running them on a Linode cloud hosting service. Let's create an alert by clicking here. This will open up a pop-up where you can select the supertrend condition. This will have 3 signals: buy, sell and direction change. We will first select the supertrend buy for this alert. Select when do you want this alert to be triggered. Since you want this to be triggered for every buy signal, let's select the once per bar close. Give the alert a name, let's give as supertrend buy. The message can be anything you want, it can be a simple text or a dynamic value. This is supported by TradingView itself, like the close price, time, plot. For this, we will just have this text for now and proceed with the create. Before that, let's get to the notification, which is the important part here. There are multiple ways to generate the notifications, like notify on app, show a pop-up, email and the webhook. This is what we are going to look at it here. This is the webhook URL, which is hosted in the Linode API server. This has to be a public IP address which is reachable from TradingView. This video will not cover that part. We'll have another video which will focus just on setting up the Linode with API server having public IP address. Now, let's create the alert. Now you can see the alert on the right-hand side tab. Now for creating the sell signal, let's right-click and clone the alert. One bug here I see is that the right-click made the alert in pause mode. Let's start it again. Since this is a clone, it will have the same settings, we just need to edit the values for sell. Update the condition to be sell. Change the alert name to sell. For the message, here now I am going to use some JSON value which can be passed. I am going to send the ticker, alert type and then the close price. Notification is same as the buy. Now we have the buy and sell alert. Once the alert conditions are met, it will show up in the below widget. Also, the webhook signal will show up in the below webhook receiver window. Now, we need to wait for the condition to be met. I think there might be one sell alert coming soon. If you notice, though the sell signal shows up but the alert did not come, since the condition is to trigger the alert on bar close. Okay, finally the bar closed and the sell signal is true, we got the alert. Got the pop-up, alert log and also the webhook receiver got the message. Since for sell alert, we had the JSON with all the values, we can see all those data like ticker, alert type and price. We can get more dynamic info, which is in TradingView documentation. Now, we need to wait for the buy signal to see the other side. I am pausing the video for a while until it get close to generating one. Okay, now we got the buy signal. In this case, we see the message with just a static text message which we have set. Now let's see how to clear the log and delete all the alerts. First let's clear all the logs here. Now, we can right-click and delete the alerts. This section focus on VM on cloud. How to create a Ubuntu VM on the Linode. How to start the API server, explained in another session which is listed in the description below. How to protect the VM, and have access to only what is required, so your information is secured. Linode account is free to set up. No payment is required until you create a VM. I already have an account, so I am going to log in. If you see here, I already have one trading node which is already running. Today, I will show how to create a similar one which I am using already. My VM IP is hidden for security reason. Let's now create a VM. Click the Create button on the top left. Select the image you need. Linode supports multiple OS and variants. I am going to use Ubuntu latest LTS version for this demo. Select your region which is close to your location, so access is faster from your network. I am selecting Fremont, California, as that's close than the other data center for me. Select the plan. This is based on your application you want to run. There are more options like dedicated CPU and also they have lots of options in shared CPU. For the trading node I am using, for running the Ubuntu, I am able to successfully run them with the shared CPU in the basic configuration, which is approximately $5 per month and well suits my need. It has got one CPU, 1 GB memory and 25 GB of data. Network usage also very lightly used, like receiving alerts from TradingView or occasionally SSH into them for monitoring or update. Give it a label. Add a tag. Also set up your password which is used for SSH access later. I already have the SSH keys uploaded for the other nodes. I will select this, so it will copy when this node is up. The SSH keys can avoid using password and trust your machine. We can skip the VLAN here. If you really need a backup of your data, then select them. I am not going to select it right now. Also private IP if you have one. Click the Create Linode. This process will take a couple of minutes. This will go through provisioning, booting and running. Once it's running, you will be able to launch the console directly from the web itself, and see the boot up process, setting the cloud config etc. You can also see the IP address already allocated for this machine. Now it's up, let's log in. I am able to log in to the machine using the password provided during setup. But, we will create a user for regular use, since root user is generally not recommended. I will close this console and will use my terminal app to SSH into the machine. If you notice, it did not ask the password for the login, since my machine SSH keys are already copied to the VM. We'll create an API server which is also linked below in description. Now, the API server is set up. Let's see if we can access the API server to get the version call which we have in the code. I am firing this API from my home machine to the VM IP, it's public IP and reachable from anywhere. Yes, I am able to get the response. Let's navigate to the Firewall tab on the left menu. You see here a firewall rule already exists. This is my existing trading node firewall. Let's create a new firewall by clicking the Create Firewall button on the top right. Let's give a name and also tag the linodes for which the firewall needs to be applied. Here, I am selecting the newly created demo node. The firewall is created, but there are no rules. It comes with empty rule set and accept as the default behavior, so still it's not protected. Now click the firewall to create the rules. We are going to create 2 rules. One for SSH access from your home machine. Second for HTTP access from your home machine and from TradingView platform to receive the alerts. First, let's create the SSH rule. Give a description, but let the other protocol and port settings to default. In the IP address section, we are going to give the home public IP address. But where to get them? There are some websites which can show your home public IP. I am using whatismyipaddress.com, which will display your IP. I have hidden the IP address for security reason. Copy the IP address. Here, I am going to give only the /16 instead of /32 again for security reason to disclose my full IP address. But when you set it up, you should give the full IP address /32. So, it will allow only your home IP and not for anyone in that /16 range. Add the rule now. You can see that the firewall is now created with one rule for your home IP address range. By default the firewall accepts everything, but we need to change it to drop, so only the rule match will be allowed. Now, let's check if it's working fine. Ping the IP address. Good, it does not work, since we added rule only for SSH and not for ping traffic. Let's try SSH now. Yes, it works. Let's try if the HTTP is working. No, it's not. You can see the page is keep loading, since we did not add the HTTP rule yet. Let's add the HTTP rule now. Give the description. But here, we are going to change the default port 80. Since we have not yet redirected the port 8080 to 80. Port redirection is covered in the other video listed in the description. Give the same IP address range. Then add the rule. Now, let's save and check the version call. Yes, it works now. One more final change we need to do. For the TradingView IP to reach your server, we need to add them too. Let's go to TradingView.com and create an alert. In the help section of the webhook, you can get the details of the IP address you need to add it to the rule. Let's get all of them and add one by one. Here, we are going to add with /32, since you don't want to open a range. Finally, you can provide the trading alert URL and you are all set. Check to make sure your firewall rule got the correct SSH and HTTP IP address needed to access from your home and from the TradingView platform. You can check all the stats like CPU, memory, network stats in the Linodes tab. Hope you learned how to set up the Ubuntu VM on Linode. Before delving directly into the API setup, it's beneficial to acquire some foundational knowledge about the protocols employed by Etrade for the configuration. While not unique to Etrade, understanding these protocols is crucial for most API setups. Accessing any API typically involves a series of significant steps, with authentication and authorization being key components. Successful authentication grants access to the resource, while authorization dictates which resources can be accessed. Essentially, it's about validating identity and defining permissible actions. Though various protocols exist, one of the most widely used is OAuth. Etrade utilizes OAuth 1.0, an authentication and authorization protocol based on request and access tokens. Despite its deprecated status, Etrade and some others still employ it. OAuth functions exclusively for web applications and isn't suitable for mobile applications. While it offers robust capabilities, its complexity may pose challenges for user-friendliness. It's worth noting that OAuth 2.0, the widely adopted successor, has superseded OAuth 1.0, marking a significant advancement in authentication and authorization protocols. Let's talk some details about OAuth 1.0. It has got 3 stages. First is to obtain an unauthorized request token with your API key. Then, you authorize that token using your login credentials, and exchange the token for an authorized access token. With this authorized token, you can access the resources. So, how it maps to Etrade API interface. Service provider is the Etrade. Consumer is your application or the script, and the user is you. As I mentioned earlier, why OAuth 1.0 is not user-friendly, since we have an intermediate web interface requirement, where this authentication is required through Etrade login. These are the APIs mapped to each layer, which is defined in the Etrade documentation page. I will go through those in detail now. The Etrade documentation meticulously maps these APIs, and I'll guide you through each one. To access them, visit developer.etrade.com and select the documentation link at the top of the page. This comprehensive page contains details on all the APIs supported by Etrade. I'll navigate through each API pertinent to the authorization section, with clear documentation for each, outlining both request and response elements. Sequentially, I'll explain how to access specific resources, such as retrieving quotes. Before delving into the APIs, the initial step is obtaining the API key from Etrade, serving as the starting point. To do this, visit the Getting Started link at the top of the page. Click on the provided link to acquire the API key. If you've already logged in, it will directly take you to the page. Otherwise, log into your Etrade account. Additionally, if you already possess an API key and need to retrieve it, this is the place to do so. The API key information will appear in a pop-up with a green screen at the top of the page. Unfortunately, for security reasons, I can't demo this section. Now, let's dive into manually executing these APIs using Postman. I've positioned the browser on the left and Postman on the right, which is utilized for crafting API requests and testing them before initiating automation. In the Etrade documentation, I'll be performing all the authorization APIs, starting with the Request for Access API, specifically the Get Quotes API. In Postman, I've already established the settings required for these 4 APIs. To safeguard sensitive information, such as the API key and secret obtained from Etrade, I've created environment variables to store them. This way, I can pass them in the API requests without revealing the confidential details. The initial API is the Get Request token. If you compare the documentation with the Postman setup, you'll notice they align. It's a GET request with parameters, employing OAuth 1.0 as the authorization type. Keep the signature method as the default. Supply the consumer key and secret through the variables, leaving the access token and secret fields empty. Set the callback URL to OOB. That's all. Click Send, and you'll receive the request token and secret necessary for constructing the subsequent URL. Moving on, the subsequent phase involves authorizing the application. As mentioned earlier, this is accomplished through a web URL rather than an API request. The key element here is your API key, which I'm concealing in this explanation. The token, on the other hand, is the one obtained from the GetRequestToken API. Construct the URL using the key and token, then press Enter. This action will direct you to the Etrade login page. Once logged in, you'll navigate to the Terms and Agreement page. Since I'm already logged in, it redirected me directly without requiring another login. Accept the terms, and you'll receive an identifier text. Now, we've successfully completed 2 steps, and the subsequent one is obtaining the access token, the final API in the authorization process. Again, this is a GET request, and the request parameters are similar to those in the request token step. However, this time, you need to pass the token and secret returned from the request token API. As this is an API request, the returned values need to be decoded using URL decoding, and then copied into the token and secret fields. Additionally, include the verifier, which is the text value obtained from the web authorization application step. Press enter, and you'll receive another token and secret. This pair will be utilized for accessing all the resources moving forward. Allow me to demonstrate how to access a resource API. I am going to demo the GetQuotes API. This, too, is a GET request. The only modification required from the GET access token step is updating the token and secret. Utilize the values returned from the GET access token API. Similarly, convert them to URL decoded format and paste them into the respective fields. Once completed, press enter, and you'll receive the comprehensive quotes for the requested symbol. Now, let's implement this knowledge into automation using Python and some OAuth Python packages. The auth.py file contains the construction of API requests related to authentication and the parsing of responses. The chosen package for this purpose is rauth, specifically utilizing the OAuth 1 service module. To begin, initialize it with the relevant URLs, API key, and secret. Once initialized, you can proceed to use APIs such as GetRequestToken. Then, construct the URL for web-based authentication. This is the only step that requires manual intervention, as OAuth 1.0, as explained earlier, is not intended for non-web-based applications. The third step involves obtaining the access token. In the market.py file, there's a small function designed to retrieve quotes. In the main file, I initialize the authentication session. Once initialized, I use the same session to set the account and, finally, obtain the quotes. Let's witness this in action as the script is executed. As observed during script execution, for the second step, the script prints the constructed URL. This URL needs to be copied and pasted into the browser to obtain the verifier, which should then be copied and provided back to the script for the subsequent step. Eventually, we successfully retrieved the quotes for Apple stock. Let's quickly verify if the price aligns with Yahoo Finance. Indeed, it matches. A couple of points to keep in mind. The access token remains valid for 2 hours of idle time and expires if no resources are accessed. However, you can use the Renew Access Token functionality to obtain a new one if it expires. Additionally, regardless of renewal, you need to authorize the application daily, and this authorization resets at midnight CST time. Now that you're acquainted with the basics of OAuth 1.0, understand how to map it to Etrade actors, and grasp the corresponding APIs, you're well equipped to implement your automation. Hope you enjoyed the video. Please subscribe to my channel if you like to watch similar videos and help my channel. Thank you. See you in another video.